Okay, I'm going to work through question 3 on page 252. Remember that the textbook does it in a different way, so I want you to look at this method, which is foolproof. The problem is about 3-point charges that are in a straight line, and the charges and distances are all given, and they want you to work out the resultant electrostatic force on Q2. Therefore, we need to focus on Q2 and the influence that the other two charges will have on that charge. Therefore, if we then look at the charges, just in another sketch, then the first thing that you must do always when you work anything out in electrostatics with forces, you draw a free body diagram. So the free body diagram will look like this. Remember, we are focusing on Q2. So Q2 becomes my dot, and then I'm looking at the influence of Q1 on Q2. Therefore, it's a negative charge. It will attract Q2 to the left, so the force of Q1 on Q2. The influence of Q3 on Q2 is a force to the right because it's a negative charge that will also be attracting the positive charge to the right. I then choose my direction to the right as positive for my calculations. I set up my equation like this. The net force or the resultant force is equal to, and very important, start with the charge or the force that is in the positive direction. So the positive direction is to the right. Therefore, the FQ3Q2 is first, then minus FQ1Q2 because that one is to the left. So now I just use my Coulomb's law. KQQ over R squared, it is R32, so it's the distance between charge 3 and 2, which is 0.5 meters. You have to do it in meters, and negative minus the force of Q1 on Q2. Now I just substitute my values. Please make sure that you substitute the correct factor here for nano. It's nano coulombs, so therefore we will work with 10 to the minus 9, and remember, you have to put it in meters and remember the square. If you then calculate that on your calculator, you get minus 1,46 times 10 to the power minus 6. That means it is a negative force, a force that is opposite to my positive direction, which was to the right. Therefore, it is 1,46 times 10 to the minus 6 newtons to the left. You have to use the negative sign in this way and put it into words as to the left.